Okay, so what if the biggest clue about alien life isn't on Mars or in some far-off galaxy? Imagine it's hidden in the air of a world only 124 light-years away. I'm talking real info here, not sci-fi. The James Webb Telescope, along with some super-smart AI, found something shocking. On the exoplanet K2-18b, researchers spotted stuff that shouldn't be there unless life put it there. This could be the first crack in the universe's silence, maybe even change how we see life outside Earth, and how we see ourselves too. This wasn't some big announcement or flashing lights. It was like a super in-depth look at starlight. The Webb telescope used its tools to grab light as it passed through K2-18b's air. This gave us a peek at what's floating around up there. At first, the team looked for common gases like carbon dioxide and methane. But they found more. They saw traces of dimethyl sulfide, DMS, and dimethyl disulfide, DMDS. Here on Earth, these are big clues for existence of life, usually from tiny ocean bugs called phytoplankton. And the AI that found this stuff? It's serious. Trained to spot weird chemical combinations in space data, it found the DMS signal with crazy confidence. Scientists are super hyped. But hold on, K2-18b isn't your normal planet. Discovered back in 2015, it's a Hycean world, basically, a bigger Earth with a thick, hydrogen-filled atmosphere and probably a global ocean. Think Earth, but bigger and with lots of hydrogen clouds. Hubble had already hinted at water in 2019, but the info wasn't clear. Now, Webb's giving us a much better view. While other AIs looked at the data too, a special quantum AI from a lab in Geneva really nailed it. Instead of just hunting for known stuff, this AI dug into how light waves acted and looked at connections human scientists might miss. What it found wasn't just molecules, it was a pattern that looked strangely like life. The Cambridge team thinks that the DMS and DMDS might be coming from alien microbes in a huge underwater ocean. These microbes could be spitting out sulfur stuff into the air, just like some bugs here on Earth. The planet's clouds spread those life signs across the universe, right to our telescopes. What makes that theory more solid is the presence of methane and CO2 in the same atmosphere. However, not everyone agrees. Soon after the Cambridge team shared their findings, some Oxford researchers did their own look at the Webb data. They couldn't find the DMS or DMDS at all. Their models say the signals might just be errors. Quirks in the telescope sensors or mistakes in how the data was processed. To make things worse, the DMS signals are missing other stuff that usually comes with sulfur made by living beings. It was a letdown. What looked like an awesome sign of life might just be a trick. Or could it still be real? This discussion is bigger than just some molecules on a far-off world. It's about how we define life and how we even look for it. For ages, we've wondered if we're alone. Now, with powerful AI and telescopes in space, we might finally get an answer. But that answer might bring both excitement and disappointment, pushing science to its limits. Cambridge sees a pattern: DMS, methane, and maybe ammonia. It's not just random molecules, it's a sign too clear to ignore. The Geneva AI didn't just spot stuff, it found connections that humans would likely miss. Still, Oxford's not wrong to be careful. Amazing claims need rock-solid proof. They think the AI might be seeing things, finding patterns that aren't really there, a fancy illusion in math. Here's the tricky part: what makes quantum AI strong also makes it prone to making error. It doesn't just look at information differently, it thinks differently. It spots relationships over time, co-absorbed chemicals, and weird wave patterns. These patterns can point to life, but they could also just be the AI's own way of processing things. Trusting it means stepping into the unknown. Guess what? The next piece of the puzzle is already here. The Webb telescope is now zooming in on K2-18b with another tool named MIRI. It will scan the mid-infrared, where molecules like ammonia and DMS shine brighter. If MIRI sees the same molecules, especially ammonia, then the AI's finds get a major boost. When different tools and methods point to the same thing, even the skeptics at Oxford will listen. As of now, we're in scientific limbo. Wonder and doubt are clashing. Just as tension was up, a little birdie leaked stuff from the European Space Agency. Word is that MIRI might have already found ammonia in K2-18b's air. Now, ammonia might not sound exciting, it is in cleaners and fertilizer. However, on a planet like K2-18b, it means a lot more. Ammonia isn't supposed to last long there. Sunlight should break it down unless something's constantly making it. On Earth, that something is life. Bugs in the ocean release ammonia. Finding it on K2-18b could mean the same thing's happening out there. If that's true, it's the third huge sign of life in the same spot: methane, DMS, and now ammonia. As MIRI's data gets crunched, the Geneva AI is already looking at it. Early results are stunning. The AI spotted how the ammonia axe matches up with pressures that would allow liquid water to exist under the clouds. Pile that on top of the sulfur and nitrogen cycles, stable air, and suddenly it looks like alien plankton are alive and well in a hydrogen ocean far away. That's not sci-fi, that's what the data show. What makes it even more powerful is that these clues aren't random. Different web instruments see them at different wavelengths. They're all pointing towards life. Maybe for the first time ever, we're going beyond guessing. This isn't just hints, it's real chemical evidence that looks more and more like biology. K2-18b isn't just another point on a map. It's becoming a real option for alien life. Let's think it over. DMS, methane, carbon dioxide, and now ammonia. You can find each of these chemicals in space, but not like this. Not together, not in these amounts, and not on a planet that looks livable. When we see this mix on Earth, it means only one thing: life. However, science is careful. It goes step by step, which means replication is everything. Follow-up studies are underway, like redoing older data, improving air simulations and lab experiments to see if these chemicals could show up without life. So far, the answer is leaning towards no. Ammonia, in particular, is a major deal. On K2-18b, it shouldn't last long in that environment filled with sunlight. The fact that we're seeing it implies that something is making it. Add that to methane, and the case gets stronger. Something might be keeping this chemical balance going. On top of that, the AI isn't just naming stuff. It's mapping relationships, how compounds affect each other, air pressures, temperatures, and how light is absorbed. It's discovering rhythms. Life isn't frozen, it goes up and down. It breathes and it cycles. The AI seems to have found life-friendly chemicals and the dance between them. Let's not miss how special this is. This isn't aliens and spaceships. It's quieter, subtler, and maybe more amazing. We're not hearing words or seeing towns, we're reading the breath of tiny bugs in alien air. Think how this changes things. If life can appear on a mini Neptune with hydrogen air, then the rules for life change completely. It doesn't need Earth conditions or sunlight. It may only need chemistry, heat, water, and time. If that's true for K2-18b, how many other worlds fit this wider definition of livability? That's the thing, K2-18b is just one of thousands of planets we've found. If it's already showing signs of life early on, then the floodgates might be opening. What if we start scanning other Hycean worlds? What if AI gets better at spotting markers? We may be at the start of a new study for life, where life isn't rare but somewhat inevitable. Not everyone agrees that this is the case. Some scientists warn against jumping to conclusions and say the AI is outpacing their skills. Some scientists are attempting to simulate how JWST's detectors behave under different observational conditions, and skeptics raise concerns such as, is the AI seeing things? Well, it's up to science to figure it out. It is also important to note the ethical and philosophical considerations surrounding the study of extraterrestrial life. Regardless, this data is revolutionary on the basis that it can be repeated using multiple means of analysis in order to derive similar results. This means the system is reproducible with photons and algorithms. The big question is how common this life is. Is K2-18b rare, or just the first? If it's the latter, then things are insane. This new era means there will be future trips and search for life as well, with the JWST providing the first clues. In the years, the Nancy Grace Roman Space Telescope and aerial mission will assist in discovering life in exoplanet atmospheres. Beyond that, the possibility of sending probes to planets increases with new breakthroughs. In conclusion, the universe is now starting to speak to itself.